consider the second case. Now we want to find the confidence interval for mu based on a sample x1 to xn, where x has normal distribution with parameters mu and sigma squared. But now both mu and sigma squared are unknown, so all that we have is just the sample. And the significance level is given by alpha. So it means the confidence level is 1 minus alpha. So we have the following thing, the transformation x hat, x dash minus mu over s0 divided by square root of n is just the t-student distribution with n minus 1 degrees of freedom. This is the distribution discovered and described by William Gusset, who wrote under the nickname of student. That's why, to honor him, this distribution is called the t-student distribution. Okay, so this is a little bit different distribution with a little bit different density function graphs, and the graphs are dependent also on various degrees of freedom. What you have to remember now, that if n is quite big, this distribution does not differ from normal distribution, and this is very useful for small samples or for cases where we, for example, don't have anything. We don't have neither mu nor sigma squared. Okay, so in this case, the confidence interval is given by the formula x minus s0 divided by square root of n times t of 1 minus alpha by 2. It's a quantile of the student distribution with n minus 1 degrees of freedom. And the second end of this interval is with the same but plus. So we have a big similarity to the previous formula for confidence interval, but we cannot use the standard normal distribution because we no longer have it. Now we have to use the t-student. And let's recall that S0 is under the square root. So this is sigma xi minus x dash, the mean of the sample, squared, and we sum it up from I equal 1 to n, and divided by n minus 1. Let's consider the following example. We have caught 10 fish, and the weights are given here in grams. We may assume that the weights have normal distribution with parameters mu and sigma, but of course we don't know neither mu nor sigma. We are to find the confidence interval for the mean. At the level of significance 0.05, it means the confidence level is 0.95. So first of all, if you calculate, there are 10 fish, so number of degrees of freedom is n minus 1, which is 9. We shall not be using the normal distribution, standard normal, but we have to use the t-student because nothing is known, neither mu nor sigma. So first of all, we calculate the mean of the sample. We sum up all these, divide by 10, and obtain 344 grams. That's the mean. Now we have to find s squared. This is 1 over n sigma xi minus x dash squared 968.8. So s is square root of this, so this is 31,13. So the value of t distribution at 1 minus 0.05 by 2 with 9 degrees of freedom is t of 0.975 with 9 degrees of freedom, and we read it from the table. It equals 2.26. Now we substitute the formula for the confidence interval. So the confidence interval is, this is x minus s divided by square root of n minus 1 times t of 1 minus alpha by 2 and n minus 1, and the same with plus x plus s by square root of n minus 1 t of 1 minus alpha by 2 n minus 1. Okay, so as you can see, we just substitute the values that we have, and finally we obtain the confidence interval more or less between 320 and 367. It is widely known that the formula in statistics seem to be quite monstrous, horrible, but in some way, we can scheme all the formula for the confidence intervals for any possible case. So, the formula for the confidence interval for the mean of the population is in each case more or less the same. This is equal to the mean of the sample plus minus s star divided by square root of n0 times u of 1 minus alpha by 2. Well, and each of these things are a little bit different in each case, but the idea is practically the same. So, x dash is always the mean of the sample. That goes without saying. S star is some approximation of the standard deviation. N0 is either n or n minus 1, depending on the case. And u1 minus alpha by 2 is a quantile. Okay, what do we have in the cases we have considered so far? In case the feature investigated has normal distribution with parameters mu sigma and sigma is known, we take as sigma the sigma which is known, and the quantile is the quantile of standard normal distribution. You know this table very well. And n0 is exactly equal to n. Okay, what happens if the sample is small, or if we don't know the variance of the distribution, but still the distribution is normal? In this case, we can use the t-student distribution. Okay, so what are the three things? So S star is exactly given by the formula here. This is square root of 1 over n and sigma xi minus x dash squared. It's just the standard deviation of the sample. N0 is exactly equal to n minus 1. And u, the quantile, is just the quantile which we take from the table of t-student distribution for n minus 1 degrees of freedom. Okay, third case. By the theorem of Lindeberg-Levy, for very big n, regardless of the distribution that we have, we know that then the distribution tends to standard normal anyways after some transformation. Therefore, we can approximate everything with standard normal. So in this case, again, we are using as the approximation of standard deviation the unbiased estimator, perhaps you can recognize, but the formula is given here. N0 is just n, and u, the quantile, is just the quantile of the normal distribution. So I hope it is of some help, and let's keep these formulas very, very important. If we took many samples, then the value of the mean in 95% of them would fall into the confidence interval. And the real value of parameter, who knows where it really is? It is out of reach.